Okay, now let us look at this. How do we use the second derivative test for the local mean and local max? So we use the second derivative test for the concave up and down, but now we want to use the second derivative test for the local max and local mean. These are the rules. First, find out the f prime of x and critical numbers. Find the first derivative and find out where the first derivative is 0 or undefined. Then find out the second derivative and all the critical numbers. Suppose here the critical numbers are c1, c2, c3 and so on. And what you do is, after you find out the second derivative, you plug in each of the critical numbers in the second derivative and look at the sign. If the second derivative is positive, then local mean, because second derivative positive means concave up, right? Concave up means there is a local mean. If the second derivative is negative, it is concave down. That means this figure will look like this, concave down. So there is a local max, right? When you plug in that C1 or C2 or C3, whatever, and when you plug in, if you get the second derivative positive, then there is a local mean. If the second derivative is negative, local max. If the second derivative is equals to 0, then undecided, we will not know what will be that. Will that be local max, local mean, or point of inflection? Because the second derivative equals to 0 does not imply the point of inflection directly. We'll have to do the more work for that. Ci may be point of inflection or not. We need to use the first derivative test to on left and right of Ci. We'll have to check whether it is increasing, decreasing, decreasing, increasing, what is happening there, and we will decide from that. Okay, let us do an example. So we want to find out the we want to use the second derivative test to find out the local max and local mean. So let's follow this step. What is f prime? It is 4x cubed minus 24x squared plus 0, right? So now we need to find out critical points. Since there is no x in the denominator or the root, so it is defined everywhere. So we don't have to worry about where the function first derivative is not defined for the critical point. So what we do is you set that equals to 0. What do you get? When you set that equals 0, let me take 4x squared out. What is left is x minus 6 is left, right? So if you set 4x squared equals to 0, what do you get? X equals to 0. And if you set x minus 6 equals to 0, what do you get? X equals to 6. These are the two critical points, right? Critical numbers. After you find out the critical numbers, find out the second derivative. What is f double prime? You find out the derivative of this one, right? That is 12x squared minus 48x, right? So what do you do with that? Let us plug in 0. So at x equals to 0, what is f double prime? Oh, f double prime is 0. So it is undecided case, right? So we'll have to go with the first derivative. Or you can use the second derivative for the concave up and down, or use the first derivative. Either one, you will get the answer, okay? So we'll have to do more work for this one. So let's do at x equals to 6, what do you get? 12 times 6 squared is how much? 12 times 36 minus 48 times 6. Let me use calculator for that. So 12 times 36 minus 48 times 6 is 156. That will be positive. F double prime will be 156. That is positive. So positive, f double prime positive means what? Local mean, right? So f has local mean at x equals to 6. Now we need to do more work for the x equals to 0, right? Because we were undecided. Let me write undecided. Let's work more, okay? So at x equals to 0, f double prime is 0. But how about the first derivative on the left and right of x equals to 0? This is 0 here. 0. I want to take a test point. Let's say negative 1 and then positive 1. At negative 1, what happens? We are taking the first derivative, right? What is the first derivative? It is 4x cubed minus 24x squared. 4x cubed minus 24x squared. First derivative will give you increasing and decreasing pattern, and then in that way you will be able to find out, okay? So on the left of 0, if you plug in negative 1, what do you get? 4 times negative 1 to the cube is negative 4 minus 24 times negative 1 square will be positive 1. So negative 4 minus 24 will be negative. So this will be negative, meaning it is decreasing. And if we plug in 1, 4 times 1 to the cube is 4, minus 24 times 1 square is minus 20. 4 minus 24, it is also negative. So it is also decreasing. You see that? There is no local max or local mean there, because it is decreasing and then decreasing again. Looks like the graph look like at 0, the graph look like this. Decreasing and then decreasing again, and but see, left of 0 is concave up, right of 0 is concave down. Maybe like that. So x equals to 0 is basically the point of inflection. Okay, so x equals to 0 has no max and no mean, but it has point of inflection. It has point of inflection because it is decreasing on both sides of that, and the second derivative is 0 there, right? So it is the boundary between the concave up and concave down. So basically it is the point of inflection there. Okay, I mean, you can check the second derivative too. In this, if you do the second derivative, you will see, for example, left and right of 0. Let's check the second derivative too, right? Just to make sure. 0. So what is f double prime? I want to find the sign of f double prime there on the left and right of 0. On the left of 0, let me take the test point as negative 1. On the right of 0, positive 1 again. If I plug in the second derivative, negative 1. If I plug in negative 1 here, what do you get? 12 times negative 1 square is positive, minus 48 times negative 1 is positive. So positive will be, this is positive, right? On the right, it will be 12 minus 48 if you plug in 1. 12 minus 48 will be negative. So the right side is, see, it is concave up on the left side and down on the right side. So it is basically the point of inflection. Okay, so it doesn't have local max, only the local mean, right? So let me write down the final answer. Relative mean at x equals to 6, point of inflection at x equals to 0. That is the final answer. We will do a couple more examples. Okay.